Welcome to the 30th episode of PEEPanEIP, an EIP dedicated series where we discuss an Ethereum improvement proposal and understand how it is going to make Ethereum even better. I'm your host Pooja Ranjan, and today we are going to talk about EIP-2124, that is fork identifier for chain compatibility checks. EIP-2124 is a standard track networking proposal created in May 2019 and currently is in the last call. It's related to discovering nodes. Currently, nodes in Ethereum network try to find each other by establishing random connection to remote machines that look like Ethereum node. In the hope that they found a useful pair, a lot of time and resources are wasted, especially for smaller networks. So this EIP proposes a new identity scheme to precisely summarize the chain's current status with Genesis and all applied forks by providing a generally useful fork identifier. To understand what is the fork identifier and this proposal, let's welcome our guest, Felix Long. Thank you for joining us, Felix. Without further ado, the floor is all yours.
Okay. Regarding the fork identifier, so this EIP has been around for a long time. Specifically, it's been around for about 2 years. It was implemented while the EIP was written, so it is already implemented for a long time also in most clients anyway. So at this point, it can be considered just part of the standard. And in fact, it is part of the standard network protocol since the ETH protocol version 64. So basically, there was the companion EIP, which is unfortunately still marked as draft, even though it is long out, and it is the EIP-2324. And this is basically the EIP that is actually using the fork identifier. So it's like it extends the protocol to also have the actual networking protocol to also use this mechanism. But let's talk quickly about the EIP-2124. So the situation was as follows. So in the Ethereum network protocol, since the very beginning, there was this concept of the network ID. And the network ID is a number which identifies the chain. And if we look into the specification, then we will basically see that what are the defined network IDs. So I will start the screen share now, and then we can look at the thing together. Can you see my screen now? Okay. So here is the EIP. Actually, when I was talking about the other EIP, I was also showing it. So this is the EIP for the fork identifier. This is the EIP for the network protocol extension using the fork identifier. And here is the specification of the ETH networking protocol, which is the protocol that is spoken between the nodes. So what you can see is that the very first thing that the nodes say to each other when they connect is the status message. And inside of the status message, we have the network ID. I have and then the network ID is actually, you can see some common network IDs here. So the network ID 0 was used for the Olympic testnet, which was pre-mainnet launch. 1 was allocated for the frontier network, which became the mainnet. And then further network IDs were allocated for the official testnets. For example, the number 2 was used for the modern testnet, which is long dead. The number 3 is allocated to Robson, which is still in use, even though it at this point is not useful, but yeah, people use it anyway. And the number 4 is the Rinkeby network. But actually, chain ID.network, and it shows all of the different network IDs which are in use, and you can see there are quite a lot of them. So basically, when people create alternative Ethereum networks, they usually choose a network ID, and they are all listed here. So that is the network ID. The problem at the time was that when there was the DAO, the network already had the network ID, and when it was forked, the other network actually had the same network ID. So at this point, the network ID became a little bit useless for distinguishing, the actual Ethereum networks, because there were two networks with the same ID. And we were thinking about it at the time, and then we were kind of thinking like, what can be done about it? And then we kind of thought that it would be nice to have some kind of dynamic network ID. And the dynamic number, like this, it should be like a short number, and by short I mean it should be smaller than 64 bits, and this number should somehow uniquely identify the network without having to explicitly configure it before. And then we were thinking about it, and it is actually not non-trivial to figure it out, because you cannot distinguish the networks by the Genesis block alone, because there are some networks which are created using alternative, like basically there can be many chains originate. It's not just the Genesis block. And the network ID is also not fully sufficient, because the network ID is just some number that was decided once, and if the chain is forked later, then you still have the same network ID. You can change it then, but it's like, it doesn't, the network ID is not part of consensus. So technically, if a fork is created, it could change the network ID. But at the time, it was also really, it would have meant that basically, if we wanted to actually do it for every fork, we would have to assign a new network ID for every fork, and then configure it into the clients, and there could still be clash. So it didn't really work. So what we ended up choosing is basically this idea that the fork identifier is a number which somehow contains the Genesis block hash and the block numbers of all of the scheduled hard forks that have occurred in the network. And the way it works, and I can quickly show it here. So basically, regarding the fork hash, so the fork identifier, it has two parts. It has the fork hash and the fork next. We will ignore the fork next for now. The fork hash is using the CRC32 checksum function. And the way it works is that the fork identifier for the current head of the chain, according to the node, is defined as the CRC2 of the Genesis hash, and then basically inputting into the CRC32 the block numbers of all of the scheduled hard forks that have already occurred in the chain. And so basically here in the example, you can see it. The initial fork hash is just the CRC32 of the Genesis block hash. And then the further fork hashes for the chain are basically like, it's the CRC32 of the Genesis hash. And into that goes the number of the first fork, which is the Homestead fork. And then here we can see we can compute the next fork hash by basically taking the same thing again, but appending the next block number. And in this case, it is the DAO fork.
So when you say block number, are you saying like the block number at the fork?
It is the block number at which the fork is activated. So in Ethereum, usually the forks, they are scheduled using EIPs. So you can see it here, for example, in the EIP-666, it has the high number because it was created retroactively. And you can see it here that basically this is the block number of the fork on the mainnet. So this is the activation block. And then here you can see it that this number, it goes into the checksum like this. Mm-hmm. Yeah. And this goes.
And then how do you keep track of like which fork hashes there were previously? or is it just?
No, so basically what you can do is every node computes the fork hash of the current head of the chain. And this is basically its current fork hash. So every node has a single fork identifier, and it is basically the fork hash containing all of the hard forks which have already activated at the current block. But it changes over time. So for example, if the node is syncing, then initially its fork hash is the genesis because no hard forks have passed. But once it syncs beyond the block, beyond this block, it's like 1,150,000, then the fork hash will change to that of the homestead fork. You know what I mean?
Interesting.
Yeah. So and because the purpose of the fork ID is to validate whether the node is actually compatible. And in order to do this, there has to be this validation rule, and you can have it here, as you can see it here. So basically, the way it works is that using this construction, you can generate all of the valid fork hashes. So, and this is in fact what the nodes are doing. So basically, if you want to check if some node is compatible and with you, and you are at the current head of the chain, then you just basically compute all of the checksums for all of the forks which have already activated. And if the node has one of these fork hashes, then it is compatible. Because, you know, for example, this fork hash is also valid because it is like, you know, the node is just, you know, at the genesis block at the moment, you know, because it's not synced yet, but it's still compatible because, you know, it is not past this fork yet. But if the node, for example, then activates the homestead fork at a different block number, then its fork hash will no longer be part of the set of the valid fork hashes, and so it will not be compatible. And you can see there's a big table in the EIP that also kind of explains these validation rules and like whether it is, you know, like okay to connect to the node or not, given the fork hash that it is advertising. And yeah, and you can see the explanation here. For example, if the local fork hash and the remote fork hash are equal, then obviously it is okay to connect because they are both synced to the head of the same chain, right? But we will ignore this part about the fork next. But yeah, you can also kind of see that like sometimes, yeah, there are some cases here where it's like, you know, like these cases, you just have to check the table. There are quite a number of situations that can arise depending on like which fork hashes are, you know, like available locally and which ones are not. But yeah, that's just basically it. And we can also go over the fork next. So the fork next is simply the block number of the next fork. And the next fork is basically the next fork according to what the node is thinking what the next fork is. So basically, if the node is currently in the homestead state, and then the next fork will be the DAO fork, for example. And this information is also used during the validation. It can be used to detect if the node has upgraded or not, or, you know.
What, and why would you want to connect to a node that hasn't fully synced yet?
Well, it's not so much that like the node, you wouldn't necessarily connect to this node, but the node might still want to connect to you. Yeah.
And that's necessary because...
Well, it has to sync, you know, like...
Why? Oh, okay. To explain a bit, the Ethereum network works where you start out with nothing, or maybe the Genesis hash. You connect to the network, and then you download like the history of the blockchain, right?
Yeah, kind of, yeah. Yeah, so basically, yeah, so in order for, basically the purpose of this fork, so the fork identifier, it's important to understand the fork identifier is a very abstract sort of thing. It is a, the fork identifier is simply like this 32-bit number, which can be used to detect if the node is, if two nodes are compatible. But this EIP, the EIP-2124, doesn't actually say anything about, you know, like how exactly this should be used. It's more like an abstract idea. And then we actually have the other EIP, which is the 2364. And this integrates it, for example, into the networking protocol. And this is actually also part of the protocol specification. So we can just check it in the protocol specification. And as I explained it in the beginning, there is the status message, which is sent when the peers first connect. So basically, when the peers connect, they first send the status message, and you can actually see that part of the status message since the ETH protocol version 64 is this fork ID. And then so basically, whenever two peers connect to each other, they can immediately determine if they are compatible or not based on this fork ID, which the other side is providing and you are also providing. And either side may then disconnect because they consider it incompatible.
Okay, that makes sense. So if you were to, like, say, start off at Genesis, and then while you're syncing, you get up to whatever the Homestead fork was, like, would your forecast
Yes, it will change.
or
It
your
will
fork
change all
ID?
the time during sync. Yeah.
Okay, and that's like automatic, I'm assuming?
Yeah, it's automatic. It is. This is the purpose of the fork ID is that this is automatic. Yeah. Yeah, I can show you in the code
And
if you
then-
want.
Oh no, it's okay. I'm just trying to verify the full flow. So how do you prevent, or what's the negative impact of if you had two nodes connect that were incompatible?
So basically, the thing about this is that I explained it a little bit in the beginning. So after the DAO fork, there was this unfortunate situation where there were two incompatible blockchains with different fork rules. But they were both basically, they both had the same Genesis block and the same network ID. And when this situation happens, there will be a lot of useless peer connections. And you will only find out if the peer connection that the peer connection is not useful when the node is sending new blocks, which are like invalid. So basically what you have to understand is that for an Ethereum node, when it receives a block, it will always validate the block because the block may actually, be valid and a part of the chain. So when you have many useless peer connections, which are relaying invalid blocks, it just creates a lot of additional work for the node to verify all of these invalid blocks. So it's like, basically it's just wasting the computation, because we already know they are not compatible because they have different fork blocks. So it's actually doesn't really make sense to, try and sync it anyway. You know what I mean?
Mm-hmm. That makes sense.
Yeah, so this is like kind of the goal. It's an optimization. It's supposed to make it so that basically the nodes, when they are talking to each other, they can already know before if it even makes sense to download all the blocks from the other peer, because it's actually at the current time. Actually, it turns out that in Ethereum Classic, sometime after the DAO fork, they introduced their own version of the scheme. I have no idea what it's called, or it's a bit different, or maybe they just simply changed the network ID to make this problem disappear on their side. But basically, like a short while after the DAO fork, it kind of turned out that the chain that executed the DAO fork, which is now the current mainnet, this chain has the higher proof of work value. So in practice, the Ethereum mainnet nodes, they would not sync from the Ethereum Classic nodes because the advertised proof of work weight was just much smaller, So basically, they would never follow the Ethereum Classic chain. But for the Ethereum Classic, this mechanism is actually very useful because if it wasn't there, then otherwise, basically, the Ethereum Classic nodes would always sync the Ethereum mainnet up until, hitting some block where a transaction is performed that hits one of the accounts that were affected by the DAO fork. You know what I mean? So basically, they would just always sync the wrong chain first, even though it's, not compatible. And then it would have to.
Bro, and so just to kind of I guess, repeat what you said back to you, you're saying that problem existed because the, in this case, the forecash between the Genesis and Homestead would be equivalent, which would just be the ID. But, and then that would cause issues because then you don't know, the exact thing. Is that what you're saying?
No, mostly what I mean is that, okay, so what you have to imagine is that if you have two blockchains and they are both based on the proof of work, and they both have the same Genesis block, and they both have the same network ID, and the network ID is not the fork identifier, it's this other thing that I explained in the beginning, that the network ID has always existed even before this. So if you have two blockchains and they are basically the same up to a certain block, where on one of the chains some fork happens and the rules of EVM execution change, and then on the other chain there is no such fork and the rules of the EVM execution do not change. This creates two blockchains right at this point in time, because one is continuing with the new rules and the other one is sticking to the old rules. And then basically, but the node, it doesn't really know anything about the content of the block before it has successfully imported and processed the block. So the only way by which the nodes first decide which chain they should sync is simply the proof of work weight of the chain. So they will simply look at the block headers and say, oh, this chain is heavier, I'm going to sync this one. And then during the execution of the chain, they will find out that the chain is actually incompatible. So because, for example, because some fork happens which the node is not prepared for or something. And then so at this point, there will be a huge reorganization of the chain back to the point where they split up, and then it will follow up the other chain. But it's actually, when there are long-range reorgs, it gets very, very inefficient, because it it might even continue switching back and forth between the two chains, and it's just it will basically lead to a non-functioning network. The network will eventually probably work out, but it's kind of like it's just not a very nice experience to be stuck in this like state where there's a competing blockchain which has, higher proof of work but is invalid. It's just it just messes with the logic, with the sync logic of the nodes.
Yeah, no, that makes sense. My only other question then would be, like, how does the fork hash address that?
So it addresses this because the fork hash recognizes that there is this concept of the fork block number. And if there is a hard fork is scheduled on one chain, but not on the other chain, then at the block where the fork happens on the chain, the fork hash will change. So from this point onward, in the networking protocol, we can already, when the peers connect, we can immediately decide that this peer connection is not going to lead to a successful sync, because the two peers are trying to sync two different blockchains. Do you know what I mean?
Yeah, I do. I'm just trying to sort of like explain it in a way or I'm trying to reiterate just to make sure that I have it fully clear. And I assume then, all right, I'm going to try to walk. So fork hash 0, the Genesis, like that would connect up until it's synced or if it's trying to get a block that's lower than whatever this homestead block was, right?
Yeah, so when the node starts initially, it starts at the block 0. So it is at the Genesis block, which is the block 0. So the fork hash, the local fork hash of the node, is simply the checksum of the Genesis hash. And then as the node is syncing and it is importing more blocks, at some point it will import this block, which is the block number 1,150,000, which is the homestead block. And then at this point, the fork ID of the node, the local fork ID of the node will change, or the local fork hash of the node will change. And it will change to this one, which is the checksum of the Genesis hash. And, added into this is the block number of the homestead fork. And then as the node is progressing further and syncing through the next fork block, it will add this block number to the checksum as well. And it will continue doing this until it eventually hits the head of the chain, at which point, it will just keep doing this, but at some point it will hit this state where it has synced through all of the past forks. At the moment, we have a whole bunch of forks. So it will go through, like when you are syncing, right? So you will go through the Homestead fork, Spurious Dragon fork, Tangerine Whistle fork, Byzantium fork, Dow fork, Constantinople fork, Istanbul fork, Petersburg fork, Lunar Glacier fork, Berlin fork, you know, all of these forks. It will, at some point they will all happen during the sync, you know?
Yep, that makes
And
sense.
then each time it happens, the fork hash will be updated. The local fork hash will be updated.
Okay.
So I have a
Yeah.
question related to three-way forks, like as it is mentioned in the abstract section, like this EIP, this 2124 proposal, does not give a clear separation of three-way forks. So can you elaborate what is this three-way fork, and like if is there an example that might help people to understand?
Yeah, Peter wrote this. Yeah, so I mean, it's kind of obvious, right? So this scheme is based on the fork block number. So it means that if there are two conflicting forks scheduled at the same block number, then this scheme will not work. And this is because the nodes will have the same fork hash, because the fork hash doesn't include anything but the block number of the fork. So it's like, if at some point, you know, there is this thing where you have two forks scheduled at the same block, then, like, I mean, two conflicting forks, but this is very rare, and I think the situation is very unlikely to arise in practice. So when we could see this three-way fork situation, if we had, if for example there was a, I mean, in the current Ethereum EIP process, things are generally agreed upon by some committee, and then everyone, you know, kind of, you know, implements the changes exactly as specified, and it's all tested, and then the fork activates at some future block. So usually the implementation of the fork EIPs happens first, and then once the fork EIPs are implemented and they are all tested, then the activation block number is set. But if there was a very contentious hard fork, right? And then, you know, like someone would actually schedule, like if some part of the Ethereum community would feel that this hard fork is not acceptable to them, for example, then they could create an alternative specification for a different hard fork, and they could even schedule it at the same block number. And if they would do this, then there would be like three ways to go. You know, you could not fork at all because the client was not updated and doesn't include the new code for the fork, or the client, you know, the user could update to one version of the client which implements the fork A, or the user could update the software to some other client which you know, implements the fork B. And then, so this would lead to this three-way separation. And this EIP, like the fork identifier, cannot handle this. So at this point, we would have the situation again where the two chains, the fork A chain and the fork B chain, would be competing. But yeah, but I think it is unlikely that this will happen, because why would you schedule it at the same block? It doesn't really make sense, I think. Like, usually people either want the fork or they don't want the fork. It's not like they want one fork or the different one.
Okay.
So it's kind of, yeah, like it hasn't really happened yet, you know, the situation. So it's more like hypothetical. I just wanted to give a quick overview. So these EIPs were implemented a long time ago, and you can see it here. So the fork ID, the fork identifier itself was implemented in Go Ethereum. The implementation was submitted on 8th July of 2019, and this is, yeah, just a little bit after the EIP was created. So Peter himself implemented it. This is the original pull request that implemented, and it was created. It was actually added to the Geth version 1.90. So it's quite a long time ago. And the one part of this implementation was also the implementation of the ENR field, and this is something that I'm actually not sure if is it defined in the same EIP.
Are you talking about 778 maybe?
I'm just checking if this talks about the ENR at all. It seems like it does not talk about the ENR entry. Yeah, is there maybe we made it even yet another EIP for this? No, I think no, we didn't really make. I'm actually not sure. I always thought it was part of this 2124 EIP, but it doesn't really matter. So basically, this is the specification of the networking protocol. But in the last PEEPanEIP where I was present, we were also talking about the ENR. And in fact, you can see it basically that we have the ETH ENR entry, which at the moment contains only the fork ID. So this is something to, yeah. And it says it was proposed in the EIP-2124, but I cannot actually see where exactly it is proposed. But it doesn't really, yeah. Anyway, so what this means with the ENR entry is that this information about the fork at which the node is currently, compatible with, this information is also part of the discovery protocol. So basically, when the node is discovered in the Ethereum DHT, then it is also possible to avoid connecting to nodes which are known to be incompatible. And this can be done by simply checking whether the node record of the node contains a compatible fork ID, fork identifier. Does it make sense to anyone saying it like this?
Yeah, that totally. So I was just wondering about one specific case. I don't know if if it is possible at all or not. Like in Ethereum,
Yeah.
we have different test nets, and they have their chain ID. So is it possible that by any chance, I don't know, I'm not aware of any situation like this has ever happened in past. Is it possible that by any chance, if we get the same block number for any testnet as well as for the mainnet, and then that may create a situation where we will end up with a three-way fork?
Well, so this is why, for example, we also have the Genesis block hash in the fork identifier. And the Genesis hash from the start differentiates the testnets from the mainnet, because probably the testnet will not be created using the mainnet Genesis block.
Right.
So, yeah. So in practice, I mean, if you want, we can look at. I'm actually not sure, how to really demo this. This mechanism is kind of it's an optimization that we have implemented long time ago to make sure that the invalid connections between nodes do not happen. And what I can say is that this EIP has turned out to be very useful, because with every fork that happened since then, we had it has prevented these useless connections from happening. So to this day, this even continues to work. It's not just for the DAO fork. So for example, when the Berlin fork, I'm actually not sure, did the Berlin already activate on mainnet or not? I don't know.
Not yet.
Okay, but basically, so when the Berlin fork will activate on the mainnet, for example, it is, at this moment that when some of the nodes will have updated to, we can actually check this now. I mean, it's not a good, not the best way to check it, but for example, we can just check the ETH stat. Oh, I need to. It always happens, right, with every fork, that some people do not upgrade the node for the fork, and then for some reason the ETH stats doesn't work for me, so we cannot check it. Basically, sometimes it happens that the people do not upgrade the software in time for the fork, either because they forget about it or some other reason, or they can't upgrade yet or whatever. And then basically this EIP ensures that, in this situation, the node, it creates a bit of an asymmetric situation, right? So basically your node, it will just be stuck at behind, but it can still connect, So it's like, but at the same time, if if you upgrade it to some totally different version of the software or something, or you ran the Ethereum Classic or something, then it would like prevent the connection. So I think it's kind of something that it really works for us, this EIP, and it hasn't really created any problems, but it has created some benefits. So we feel much better about the activation of the forks, because we know that this mechanism is there and it will ensure that like the invalid connections do not happen.
All right.
So it's something that just makes it a little bit easier to be certain that the fork will actually work.
So I have like a question that is obviously not directly related to this proposal, but as you have mentioned about EIP-2324, that is ETH64 fork ID extended protocol handshake, right? So
Yeah.
This proposal is extension of 2124, as I see, like by specifying how the fork ID should be exchanged between the peers.
So this is only for, you can see it here. So it's like the specification is not very long, and basically what happens here is that you have the fork ID generation and validation, which you need to implement in order to make this EIP work. And you need to implement you need to add the version number 64 to the ETH protocol to implement it. And then the status message is changed to include the additional fork ID. And then the idea is that when the status message is received on both sides, then they must both validate the remote fork ID and disconnect if it is incompatible. But the actual compatibility rules are not defined in this EIP because they are already defined here. So here are the rules, and you just have to run these rules for every new connection. That's the idea, at least. So the implementation of this, you can see it here. It was added on 30th October 2019, and it's not a very big pull request. I mean, it's 300 lines added, so it's not a lot because if you check it in a diff, it basically does exactly that. I mean, it changes some parts of the like usually the protocol version updates in Go Ethereum, they can be a bit long because some stuff has to be changed. But it's really mostly about, and in this pull request also the Ethereum protocol version 62 was removed at the same time. So I don't know, there are a bunch more changes here than necessary, but basically it's very simple. And then, some stuff is just for like unit tests, like checking that they are actually not, that the connection is rejected. So the implementation is very tiny. And this is because really this EIP just says you should have the fork ID as part of this like handshake between the peers, and they should validate it. But the validation was already implemented when the fork identifier was implemented. So it's not like it wasn't really like a very big change.
Right. So my question here with you is about the kind of the process part. Like for ETH63, there is no EIP, right? It is maintained in Dev P2P repo. So was curious to understand, like, what are your thoughts on Geth deciding to go the path of EIP standardization for this particular thing, like not implementing, adding the fork ID directly as a field to the existing repo and going by the standardization process.
Are you asking about the EIPs for the ETH?
This proposal, the EIP-2364, that is fork ID extension for the EIP-2124.
Yeah.
So this, my question is like, why we are not directly updating it in the repo directly as we did it for ETH63. Instead, we are going the path of EIP standardization to add the fork ID field in the code base.
Well, so at the time when this was written, we were kind of thinking that like it makes sense to like, and we still think this today. I think it makes sense to announce changes to the ETH networking protocol using the EIP.
Right.
And and the same actually happened for the protocol version 65, which was added like a little bit later. Actually, I'm not sure. Yeah, it was added in January 2020. We moved on to the ETH version 65, which is after this fork ID. And now we even have the ETH version 66, which is also implemented as part of like Geth version 110. So I think it makes sense to talk about talk about the protocol changes as EIPs, because while they are not it's not as critical as, like, you know, for the consensus, but it still makes sense to have some, you know, some place to announce these changes.
Yeah.
And we can make the changes in the specification, but for example, for the ETH66, we haven't made this change in the specification yet. So for example, in the specification, we are still in the version ETH65 because I haven't updated it yet for the 66. But it will eventually be updated for the 66 as well. So it's just kind of something that I feel like it's just like, you know, good practice to make the EIP for the ETH protocol changes as well.
Right. I asked this question because like last week we were discussing EIP-1474, that was an interface EIP for Ethereum RPC. And there were some suggestions on the process improvement part. So because these proposals are not core proposals and they do not require client consensus. So we were trying to figure out what would be the best way to keep these specs updated. And if it is by following EIP standardization path, that's fair enough. If not, then we can figure out some other way. So yeah, that was it. Moving on the implementation part, you mentioned in the beginning that this EIP-2124 has been implemented by most of the clients. So I was wondering, by any chance, if you have visibility of the repository of the client implementation, or maybe how much it is implemented? Is it totally implemented? So what is the status of it? Or if we can add this implementation to the proposal itself, like in the proposal as of now, we can see only the link available for Geth implementation and no other client. So is it possible to add more clients implementation there?
So it is implemented in Open Ethereum. I don't know since which version, but in the latest version, version 3.2.0, it is implemented. You can see it. They are sending the fork ID, so it's okay. It is implemented by Nethermind. It's also implemented by Bisu. And it is also implemented by Go Ethereum.
Right. So all major
Oh
clients.
no, this is the wrong test. Wait 1 second. Here we go. Yeah. And here you can see also that Go Ethereum implements version 66, and the other clients don't implement 66. Shit, I keep clicking the wrong thing. I'm so sorry. Yeah, so they don't implement it yet. So this website is the dashboard of the Hive testing tool, which basically just runs all of the protocol tests all the time, and we can kind of check it, and we can see if the clients implement something or not. But as far as I'm concerned, like if Go Ethereum, Bisu, Nethermind, and Open Ethereum implement it, I will consider it to be like fully implemented.
Right. So would it be like logical to add these links in the proposal itself? Because most of the time we try to get the list of clients which have already implemented, and it seems that most of the clients have already implemented.
Yeah, I mean this I wouldn't link to this because it just changes all the time, and it's not like the test reports here, they just change like every couple days, and we also throw away the old test reports from time to time. So it's like the links will just be dead eventually. It's like this is an ongoing thing. It just, you know, these test results are from like, yeah, it looks like somehow the sorting is wrong, but the latest test results are like from today, right? So it's like we will eventually remove the old test results, and then the link will not work anymore. But we could link to the pull request, for example. I mean, we have the pull request here, and then we can check it, for example, in the in Open Ethereum. It's a very good question. If when it was actually implemented, I guess it was implemented as part of the EIP-64. So we should probably, yeah. So here we go. So there was one which was rejected and one was accepted. So they implemented it, but they implemented it last September of last year. So yeah.
Yeah.
I mean, actually, it was resubmitted, the resubmit of the other implementation. But you can see that people eventually implemented this, but they didn't implement it immediately. I don't know for all of the clients when exactly they implemented it, but I mean, as of now, it's all implemented. So this actually contains the fork ID as well. Yeah, they added it here. So they implemented the fork ID as part of this EIP-64 change, which is okay, I guess.
Yeah, right. So I have one last question for you. It's about the status change. So while going through the proposal, I found that one of the biggest motivation for this proposal is to maximize the utility of the public nodes to ensure that resources are not wasted and tasks that are not of much importance does not consume resources. This particular proposal, this was proposed in 2019 at the time of Istanbul. In your mind, what could be the possible reason for the delay in moving this proposal to reach the final status? I know the implementation was going in the back end, but I was trying to understand any blocker, if there are, in terms of process that you would like to mention.
Well, so I said it last time about this already. So when we had the call last time. So I mean, I just think basically that nobody really cares about these EIPs, you know. So it's like I think these EIPs are most valuable for, like, you know, for the client implementers, because they can check it exactly what's the you know, what's new and what they could implement. And in the past, we also brought these things up in the all core devs call, for example, when we had some ideas for network protocol changes, we just announced it in the all core devs. Personally, I don't really care if, you know, like, what's the status of the EIP, because we will just basically, this process has mostly been a process of just negotiating it between the authors of the EIP. In this case, it's us, like, I mean, me and Peter, and the client implementers. So basically, we just go to the client implementers and, you know, like, annoy them about it until they implement it. And once it's implemented, it's like, I don't really, like, I mean, I don't have the authority to change the status. I think these EIPs should all be final because they have been implemented for a long time and they are all tested and they are very useful. So from my point of view, I think they are pretty much all final. But like, I mean, the ones that are currently in the review, but at some point it was decided that, or draft, you know, like, these things are draft, they're not even review. They're like, you know, just stuck there in the draft. But it doesn't really matter because since they have already been shipped, I think someone wanted to change. So for example, for these EIPs here, they were changed to last call because I said that, you know, like, they are already implemented. And then they said, yeah, formally we would have to go through the last call stage. I guess then, you know, someone moved it to the last call. I have received 0 feedback during the last call. So now they are just stuck in last call. I mean, eventually, you know, if I get to talk to someone who has the authority to change the status, maybe, you know, next year they will be changed to final when the review period is already like 1 year over. I don't know.
Yeah, I think that is definitely an issue. Like, there are so many proposals which are in one status and has been stuck there for just like forever. We are trying to, like, find those proposals and talk to authors and just keep it pushing towards the next status. So just for your information, the last call status has already ended, like, in September itself, 2020. And this is up to the author. They can, when they find that the proposal are ready to be reviewed, they move it to the review status, and from review. If they think that there is no major spec change is expected in the proposal can be moved to the last call. And once the duration of 14 days are over, if they find that the proposal is spec enough and it does not require any final change, then it can be moved to finals. Anyone like the author itself can create a pull request to change it to the final status.
Okay. Yeah. So maybe I should just change it to the final then. That's okay. I can do it. And so for these, yeah.
And for other proposal that we discussed in the last meeting, EIP 778, and more of the similar proposal as you're showing on the screen, like there are a few which are still stuck in the draft. So we have to keep pushing it to one status to another. If it is already implemented, I don't think there should be any reason for delay in moving from status to another status. So yes, this is completely up to the team.
Yeah, so I think basically, for example, it doesn't really make sense that these two are in draft, but this one is in review, because the one that's in review is like the later version. So it's like if this goes in, then, you know, the other ones are also, you know, accepted. It's like it doesn't, yeah. So I mean, I think so basically what I think should really happen is that these two things here, they can move to, they should basically just, probably the next one would be last call. Like formally the next status would be last call. I don't know. They could also go straight to the final. I don't really know. And then with E66, it's kind of okay that it's in review because we just implemented it and it's, you know, like, I mean, it's very useful, but I don't think there will be any further changes to this, to be honest. But yeah, I mean, these are okay. I mean, these can be in review. It's okay. They can move to the last call like very soon, I guess, because yeah. And then actually, so both of these are implemented, so they should move into the last call. And then this one specifically, the 1459, I don't care if it's gonna be in draft forever, you know. It's not really something that requires.
So if there is a proposal that has been superseded by some other proposal, we would want to put the status of withdrawn so that we can show the correct status of any proposal. So if you think that 2481 that has been superseded by anybody else, oh, sorry, that is the latest one, right? Sorry.
Yeah, no, it hasn't really been superseded. It's more like what I mean is that these two, they were like past protocol changes. They have been live on the network for a long time. And then this one is, you know, not live on the network for a long time. It was actually, you know, like only very recently was it even activated. And we really hope that by the end of this year, it will be implemented in all clients. But as I showed it earlier, at the moment with the E66, it is only available in the Go Ethereum. Right. So Go Ethereum can do it with the protocol version 66, but the other ones cannot do it yet. So it's like, I think it's okay that it's in review, because when other clients implement it, they might find some issues in this and they might want to change the specification further. So it's probably okay that it's still in the review phase. But the other ones, they cannot change anyway, because they are already implemented and we cannot retroactively change the spec because of formal reasons. So it's like, they will just, these are practically final, you know, but then this one, it's okay that, so it doesn't really make sense that, you know, like they are in draft, because this one is already in review. And yeah, never mind. This situation is just, you know, like a little bit messy, but I agree. I can move these EIPs to the final, because you already said, since the review has already passed, it's fine. I can move it to the final. And
yeah, right. Yeah. This is completely up to the author. It's just that we are trying to, you know, provide more information around what's going on with the process. We are looking into the standardization process and trying to, you know, put all the EIPs in the appropriate status. That is kind of cleanup of the repository, because it's too much like cluttered right now. So yeah. All right. I mean, this was really great. Thanks, Felix, for joining us today and talking about these important networking layer proposals. I feel it's important to talk about different EIPs to let the world know that Ethereum improvement proposals are not just ERCs and core proposals. That they are much more than that. I mean, it may not be visible from a very high level, but the contribution at the networking and interface level should not go unnoticed. As we have been looking into the EIPs.ethereum.org, there is just a fact that I would like to share with you all. Out of 352 EIPs that are listed in the EIPs.ethereum.org at the moment, only 11 EIPs are in networking category, and only 3 EIPs have made it to final status. So we already have discussed that we might have to look into the change of this status, and these are already implemented. We would want to see those proposals into the right destination. On this note, for all our YouTube viewers, thanks for watching. There are other related proposals for networking that you could be interested. You may find them on eips.ethereum.org. And if you have missed watching the episode on EIP-778 ENR that we did earlier with Felix, you may follow the recording at PEEPanEIP playlist at Ethereum Cat Herders YouTube. I hope we have covered most of the questions related to this proposal, but if you still have any question that we could not answer, you may ask the guest. We'd love to hear feedback and improvement suggestions. Do let us know which EIP would you like to see in future episodes. If you like the episode, hit like and don't forget to share it with people of similar interest. We have many more interesting proposals coming up your way, so stay tuned, keep watching, keep sharing your love with Ethereum Cat Herders. This is all of us signing out.